Hello, everyone. My name is Jonathan. I'm currently a machine learning engineer, and I was thinking over the weekend of creating a YouTube channel on how to program from scratch a transformer from the 2017 Attention is All You Need paper. The reason I'm taking on this project, well, I don't even know myself. I'm just trying to learn more about GPTs in general. But that first starts with understanding what a transformer is. And I know there's a lot of hype around the whole large language model community for obvious reasons. But let's try to dissect the model architecture and what's going on behind the scenes. So in order to do that, you're only going to need one library, and that is going to be NumPy. And this is definitely going to be a challenge because most people, when they think about programming from scratch, they typically want to use PyTorch, not that, but PyTorch. So we're not going to be using Torch today. We're going to tackle the architecture and just using NumPy. So let's start honestly. So the very first piece of this architecture, we're going to focus on the left hand side of the architecture. The first one is sort of understanding. The first piece is understanding what the input is. So when we speak about transformers, we're diving into the realm of machine learning known as natural language processing. So let's say, natural language processing, we're just feeding it a string. So you can say, I don't know, just type in any sort of sentence you have here. Hello, my name is Jonathan. Cool, right? Okay, so now we have a sentence. The first step is to really deconstruct this into a series of vectors that the transformer can actually read and understand. Because transformers, at the end of the day, they're just taking in numbers. They're not really taking in strings per se. All right. So we got to break this down into numbers. All right. Numbers that mean something. So you can think about this as sort of a series of numbers. So just to break things down further, let's say hello is the number 2. My is the number 9. Name could be, I don't know, 10 per se. Is 3, and Jonathan could be 1. All right, now we've broken this sentence down into a series of numbers. But then again, these numbers don't really mean really anything. Like, you might be asking, why did I choose hello to be the number 2, mine to be the number 9, etc. So the reason we're getting these sort of numbers is because you can think about these series, the string falls within a dictionary. So let's say we had a dictionary, a series of strings. I don't know. You can sort of repeat this whole thing and just include more strings into this little dictionary we have going on here. So like day, today is Thanksgiving. Just keep on including strings, my apologies, words to this dictionary we have going on here. Okay, so we have a dictionary. Let's just call it diction. And the dictionary has the strings we just mentioned. And it doesn't have to be in the same series. Let's put Jonathan right in the very beginning so we don't get confused here. Hopefully this is making sense. I'm learning too, so bear with me here. We're going to be learning together. So you could just keep on adding to this. If you look up the dictionary, you're going to have literally words all over the place with given meanings. When we talk about dictionaries within NLP and transforming them into sort of these numbers, we have to refer back to this dictionary. So now that we have this, ready, set, and going, let's see. We can go back to this series of numbers I was talking about here. So just to give you, a better understanding, the word hello falls within the second sort of index of this dictionary we have going on here. It's the second word of this dictionary. So to replicate, we're just going to place the number one here. That's the second. That's essentially the second, word within this dictionary going on here. My is 1, 2, 3, 4. It's the fourth word, so we're going to put a 3 there. Name is 1, 2, 3, 4, 5. It's the fifth word. It's the fifth place within this dictionary, so we're going to put a 4 there. And you may be questioning, why are you not putting 2, 4, or 5? Well, in Python, you read indexes in terms of 0, 1, 2. It begins with the number 0 here. So that's why I'm sort of reading it in that way. So to continue on, that was hello, my name is. Where's is? So 1, 2, 3, 4, 5, 6. It's the sixth word within this dictionary. Jonathan is going to be the first, so that's going to be a 0. So now we're making progress here. We could successfully converted this sentence into a series of numbers that have some sort of meaning, and the meaning really relies on the fact that they live within a dictionary that we provided. So keep that in mind. The next thing we're going to do is to give the words some sort of meaning. So as an example, let's say you were doing a project and your teacher came up to you and said, you did an amazing job. All right, you did an amazing job on this project. But let's say there was another teacher and that teacher said, you did a good job on a particular project. So in your head, ask yourself, what do you think, what word do you prefer and why? In my opinion, I would love to have my teacher saying, I did amazing in this project. And why? Because this word amazing holds more weight, all right? Oof, I did not spell weight correctly. Holds more weight. And this same meaning, you're doing an okay job, but does not hold, as much weight to it as weight to amazing. Oops, same meaning, but does not hold as much weight as to amazing. Okay, so now we have the two words, but we know for a fact as human beings that the word amazing has more weight than the word good. So we need to sort of express the weight into vectors. So let's say we have a meaningful scale. Let's define this meaningful scale. What do I mean by this? Meaningful scale. So the left scale, which can be from 0 to 1. Let's just define this from 0 to 1. And the right scale also rates from 0 to 1. From 0 to 1. Oops. 0 to 1. This meaningful scale tells me how meaningful a word is. The less meaningful a word is, the higher the left scale is going to be. The more meaningful it is, the higher the right scale is going to be. So for example, bad. In terms of the meaningful scale, if you did a bad job in a project, you can essentially say that the meaningful scale is going to be a 1 and a 0. 1 being really the word hurts and there's no really good meaning behind the word bad. So using the meaningful scale, you can say amazing. You can say amazing is essentially has the meaningful scale of 0 and 1. The word does have meaning. That's why we put a 0 here. And it's the meaning of this word holds a lot of weight, because it's really nice when a friend tells you or a teacher tells you you're doing an amazing job. That's why we put a one. But when a teacher is sort of saying, you did a good job, um, you're the word is still meaningful, but there's less weight to it. So we're going to put a 0.2 for the left side of the scale, because it's not a completely bad word, but it could be better. So that's why we put a 0.2, and we're going to give a 0.8 on the right side of the scale. So hopefully this is making sense. Amazing and good mean sort of the same thing. You're doing an okay job, but one of the two words holds more weight. So now we're expressing words in terms of vectors, and that's what we want. That's what we want to do for hello, my name is Jonathan. So that's literally the first step into this transformer, because the input needs to be an embedding. And we just sort of walked through this embedding phase, where we took each word, found the index of each word in a existing dictionary, and we're going to supply each word with a series of vectors, and where the numbers hold a sort of define what the word is in terms of context. So hopefully this is making sense. If you walked through this yourself, you literally just conquered the input embedding section of the transformer architecture. You conquered this guy. But in the next video, we're going to tackle positional encoding. We're going to sort of tackle the fact that each word within a sentence means, if it means something. So like if we were to sort of flip any word within a sentence, it's going to change the meaning of that given sentence. And this is when the positional encoding comes into play, comes really in handy. It gives meaning to the positions of words within the sentence. So my apologies. I just coughed. So hopefully this made sense. If something was off, if you found any errors here in terms of my explanation, please comment below. But hopefully I catch you guys in the next video. So nice work, and have a nice day. See ya.